Let me wait until we start the real lecture, not the questions, but I believe afterwards I will just start immediately recording. Useful also to record the questions. Okay, thanks again. So that's the function call and the prototype. There is one thing remaining, which is the function signature, right? Which is basically the definition of the function itself. And we said if you're implementing the function after the main in the same file, you should really add the function signature here. So you say double, and then the name of the function, just write this, right? Good. So this is what we went through last time. So let's see really what happens behind the scene. Like when I execute such function, what happens? So if I start from beginning, I would say we said as before, the hardware, the compiler and then the hardware, when executing the binary, it starts from the first line of the main. So here I'm defining a double variable called a equal 10. What the hardware will do, it will go to the memory, allocate the right memory space. So as we will see later on, double means double floating point, which means it's like 16 byte or 32 bytes based on the machine. So I allocate the hardware knows to allocate the correct number of bytes in the memory, right? So if this is your memory, in a certain memory location, you go ahead, allocate this memory space and initialize it to 10. And then when you do B, you do the same thing for B, and then you define C, but you leave it uninitialized. If you remember what we said in one of the lectures, if I leave something uninitialized, if I leave a variable, I declare a variable or define it without initialization, well, this is at the end a memory space, right? So it might have had something from before. So assume, I would say right now it might have, well, a value of 300. It can be anything because, and this is in fact can change from run to run. And this is the risky thing about not initializing variables is you don't know really what is the initial value if you don't write it yourself, because it's dependent on the previous programs that have been running and using the same memory space, right? So this can be anything. Just to be general enough, I would say that's something that usually people call garbage because it doesn't really relate to your program. So whatever value it is, you don't really care about it. Good. And then after doing these declarations, I go ahead and use my function, my main square, and then I pass 10 and 20. And here is the good part. This is what you really need to pay attention to. Am I going back? Yeah, it seems that I can go. Okay. So if you do this, once you do this function call, something in the hardware happens. It's called a jump, right? Or a branch. Because once you do a function call, you go to the memory space where the other function is being allocated. So if we say that this is the memory space for your function, and this is the memory space for the main, the hardware starts executing from the first line. It keeps executing instruction by instruction, doing all the variable declarations here. But once you call the other function, a jump happens, right? The program stops going through line by line and then goes to the place where this function is being executed. And once you finish, once you hit the return, as we will see later on, you will go back exactly to the line afterwards or the instruction afterwards, right? So again, when you execute a function line by line, which is like a sequential execution of like the normal programming language sequential execution, once you hit a function call, you go to the function you are calling. So you do a jump or branch, you execute this function until you hit a return. Then once you return, you go back to the instruction after the call. Maybe one quick question is, how do the hardware, well, how does the hardware know that after I finish the execution of this function, I return to the instruction afterwards? Like basically right now, once I jump from here to here, I lost track of this sequence, right? How do I know once I finish here, which place to go back to as a hardware? File offsets. Well, file offsets, that's something that is very high level, bro, and it's more like an operating system level. Here we're talking about low level hardware, so it's much more specific than that, right? It might be the same idea, but something that is much more specific. So basically the point is that Fifo Stack Well, stack has a different rule, as we'll explain right now. Once you finish a function execution, you really just pop it out of the stack. But keep track of jump size of the jump. You want to do this, but how this is done? So simply what is done in hardware, and I hope in once you take some sort of a computer organization course, you take this in detail. What happens is once you do this jump, before you do it, you save what we call your program counter. Every instruction here, we said instructions are executed in a sequential fashion, right? Like one by one. But that's even really needs some information, which is like, what is the next one that I have in mind, right? So really what happens in hardware is that if this is your memory location, if you remember our flow of the compiler thing, you do all the coding and then you have the machine code, and then the loader puts this machine code into your memory. So you have a bunch of zeros and ones that include instructions. This might be, for example, the declaration of A, the declaration of B, and then this is the function call, right? So those are instructions one by one. Each instruction from the memory perspective is nothing other than zeros and ones, which is data bits as well, right? So the memory just stores these bits. It doesn't know whether these are instructions or data, doesn't really matter, right? What the hardware does, the processor hardware does when executing these things, is that starts from the first line of the main, and then each time it increments the counter. This is usually called the program counter. That's a special register that holds what instruction is going to be executed next, right? In the first line, it's going to be, for example, the corresponding assembly of double A equals 0, equal 10, right? And then once I execute this one, the program has special the processor has special hardware that increments the program counter by default. Why do we increment by default? Because you always go to the next instruction, it's sequential execution, right? The only time that the program counter will not be incremented is when you need to do a jump, right? Because this is stored somewhere else in a completely different place. Assume this is the starting point of the my square thing, and this is, well, way blue in your memory space, for example. It's not just directly after. What you need to do is you need to update your program counter to jump here as a hardware. But also to be able to do this, and then once you finish, you go back to the main, you need to store back your program counter to know that I want to come back here once I finish this function call. And what the hardware does is before doing the jump that we are talking about from here to here, you store your program counter somewhere. Usually you store it in the stack, right? And in addition to any other like status of registers you want to keep track of, right? And so you save them in, so the simple idea is you save everything you need in a safe place in the memory before you do the jump. Once you hit the return, you finished executing your function call. You want to go back to the original place. And to be able to do this, you get everything from the safe place you stored it, right? Including the program counter value, which is pointing to the correct position you need to continue execution from. But if that's not clear, please ask questions, because that's something that is fundamental really in understanding how any programming language executes in hardware, right? And this, as you will see later on, like pointers and array handling and everything, it has a great, if you gain this understanding, you really know what are you doing, right? It's no longer a mastery that, well, I want to go ahead and do this function call, not this one. So it plays a role in every program you really write. Good. So I will look into questions, and then feel free to drop questions as well before we continue. Can you explain the second step where it says memory allocated for local variable? Yes, if you are referring to this one here, as I was saying, like you are executing instructions one by one. The first one here is you want to declare a variable a equal 10. So you go ahead as a hardware. When I say you go ahead, like the hardware goes ahead and the memory allocates the memory space that you need to store the 10 in, and then initialize it to 10, right? And then you do the same thing for B, and then the same thing for C, except that for C, you don't initialize because there is no initialization assignment here. Shabab, what's the double here? The double is a type similar to int, and we have seen double multiple times before, Shabab, in the previous lectures, right? So double is a type that indicates that this has to be a double precision floating point. Okay, question, will still jump back if there is no return statement like a void function? Yes, so that's a good question, Z. So Z is saying, well, what if I don't have a return? I keep saying you keep executing your function call until you hit the return and then go back. What if you don't have a return because, for example, here you're just doing a void? What would happen is you keep executing until you hit the end curly bracket of the function. This is your own return if you don't have any return. So you keep executing everything. Once you are done with this function, you just go back. Ryan, what do you mean when you say stack in regards to the memory jump? Well, I don't want to go into detail in the actual memory structure, but memory usually, well, in a coarse-grained way, is divided into what we call stack and heap. Usually from the programmer perspective, in the heap, you keep the global variables, the things that will still always be available until you execute your program. But in the stack, you keep the values that keep it changing along the execution. Like, for example, any local variables of functions are stored in the stack. And generally, and later on I have an animation about this, but simply if you look into your stack as a big memory, every function has its own memory region inside the stack that holds all the variables, all the local variables of that function. Good. And once the function call finishes, this stack is being deallocated, right? So it just gets removed by default, right? As once we continue this example, I guess it might become a little bit clearer. Okay. Is it possible to put functions above main? If so, is it even worth doing it? Yes, it's possible to move the whole implementation above the main. From the previous lecture, if you remember, we said the correct approach is really to have a separate header file and source file for your functions. Don't even write them in your main file, right? Make it more organized, similar to what we do in labs, right? Good. So let's continue executing because this will explain things a little bit. I just remove some of that here. And then we said this is our main. And this is our function memory space. Okay. Why do we have, wasn't it D? Well, we said those are specifiers, Mayar. Like the original D1 is simply if you wanted to print like an integer. But if here C is a floating point thing. So in fact, it should, if we want to be more precise, it should be LF. Some compilers will give you warnings, right? Because double is a double precision floating point, not a single one. So it should be LF as a long floating point, right? But yeah, so there are multiple specifiers that I guess in one of the slides we had that, right? Okay, so going back to this example, so we did the initialization, we jump into the function call. What happens now is very important, is to understand what really a function call means. Here I passed A and B, right? So if you pass values to your own function call, what really happens is the first value goes to the first parameter. Oh, this should be that. The first variable goes to the first parameter. The second value goes to the second parameter, right? So A goes to X and B goes to Y. So if I execute the function call, what happens is X gets the value of 10 and B gets the value of 20. Good. And then right now I am in this memory space of my main square. So I just, well, do X equal X multiplied by X. So I square X. So X will change from 10 to 100. And then square Y, this line, right? I'm moving right now line by line inside my function. This goes to 400. And then I also declare a third variable here called Z. That's inside the memory space of my function. And then this will be simply the main square of both. All of this, as you can see, has no effect on the main variables yet, right? And that's very important. Good, because everything is happening locally in your function, right? All the values are being updated inside your memory space, which is a completely distinct memory space from the original main memory space, right? So in other words, inside the main, there is no visibility at all to all the changes that are going through. Good. Then after doing this line, here comes the magic, is you want to transfer the updated value through the return. So when you do the return, you are taking the return into your C. So I guess you might imagine this by now is that Z will go to C, right? So C will get updated. Well, this is all, and then come on. C gets updated to the Z value, right? So we just copied Z to C. Good. But before this, there is another step that has happened, which is once you hit the return of the function as well, as I said like a couple of minutes ago, you deallocate all the memory space that is allocated to this function, right? So once you hit the return, all those like local variables that I used as scratch for the calculations inside the function, they get deallocated. So no longer memory space is assigned to my main square because the function call has finished, and then C is being updated. Good. A very, very important note is that A and B didn't change at all, even if X and Y has it changed inside your function itself. Why? Because we did what we call passing by value. So we only pass the values of A and B. Pass by value will create a separate memory space inside the function itself for X and Y, copy the values, and then update them locally in X and Y. So A and B are not touched at all, right? Later on, we will see, well, we have seen this a little bit in the scanf. If you want to pass a variable to a function to get changed, then you will put the and here, and then this A will change. But let's keep this for later, right? Questions? So Ryan, you can use the same variable names, but in fact, it's not recommended. That's if you really want it, that's correct, but that's something that is not good. Why? Because usually your variable names, and that's also a good programming practice, should reflect the use of your variable. Like that should have some kind of physical meaning, right? Not just A and B and X, Y. Here we are just using this for educational purposes. Another reason is we wanted to show that A and B from one side and X and Y from another side are completely distinct variables. They are not the same. If we use the same names, but we say these are separate variables, it might be a little bit confusing. But seeing that A and B and X and Y are really different names in completely different memory space, this shows clearly that when you pass a value to a function, you're just copying the value in another memory space, but not modifying it, right? Are the variables being stored twice? Yes, that's the important point, is that the values are copied because you created new memory spaces for the function call. X and Y are local variables that take the copy of the value of A and B. So yes, you have originally at the very beginning before you update X and Y. Here, X and Y and A and B has exactly the same value. So 10 exists in two different places, 20 exists in two different places. Why that's the case? That's not a duplication, because later on, if you update X, A still has the value of 10, so you don't lose 10, right? So that's something really you can try on your own, is that after, for this printf, if you wanted, you could also print A and B, right? You will see that they are still 10 and 10 and 20, right? Even after the function call. Good. Dennis, Professor, how exactly are we supposed to add a test case for question? So let's keep the lab questions either like I take a few minutes at the beginning of the lecture or after the lecture, but not in between because now we will break the flow, right? So let's not focus on lab questions during the lecture. So if you call the function with A and B, I will come into this Sufi in detail, right? So we will have another example of how we do the pass by reference to want to update A and B, right? Will be changed, but like the short answer is yes to your question. Okay. Good. This is the question that one of you asked. It is, what if we don't have a return because it's void? Well, until you really in the closing bracket. Okay. Okay, we went through all this. That's good. This is we already mentioned at the very first lecture, is that the main is the first, well, that's the first called function by the compiler or the hardware, and the first line of the main is the first line being executed in any program in C. Control flow returns back to main function. We also mentioned this return statement takes you back to the calling function. A non-void return type must return one and only one value back. That's also we said last lecture, which is every function in C, you either return nothing at all, which is void, So you don't even need a return statement, or you can return at maximum a single variable, right? And if you do this here, you have the return type. So for example, for my mean square, I return it z, right? Or like in other words, I can just return an expression which kind of gets evaluated to also a single value, right? But you cannot return multiple values from a function in C, right? And that's one reason why we might need the pass by reference or change the input parameters themselves, right? Good. That's another function. This was related to also something we mentioned, is that if you put the implementation of the function before the main, you really don't need the signature of the function because the full implementation already exists in the main scope, right? Here, let me see. So that's really it's just a different function that returns the max of two numbers. So nothing really nothing that is really kind of special, except one small note, right? Which is, if you think in this code, max takes two input parameters, both are integer, right? But when I call it in the function call here, what I'm passing A and B. But what is the type of A and B? A and B are float. Is that even possible, right? So the function takes integers, but I'm passing floats into them, right? Good. This is later on, we will again take the general rule of that. But in C, you can really do what we call well, automatic type change, right? So, or casting in other words. So float is the general case of int, correct? If you just truncate any float, it will return into int, right? So the compiler is smart enough, the C compiler tool chain is smart enough to say, well, I can really transform the float into int by just truncating it, right? And then I will just convert it to int myself. So if you pass something like 10.5 and 11.5, this will end up being 10 and 11. And then what you will return is you will return here. Well, this expression is a little bit complex, but what it says is that if x is larger than y, then you return x, otherwise you return y, right? So in that case, I would just be returning 11. But the point is that the return value is int. So I really lost 11.5. I just truncated it. Good. This is usually called typecasting, right? Or to be more specific, it's downcasting because you move from a higher type, which is float, to a lower type, which is int. Okay. Don't worry too much about this for now, right? It's just more like an if statement, but a compact format, and we have also examples about it. But simply what it says again is, it says if x is larger than y, which is the question here. If that's the case, return the first choice, otherwise return the second one, right? Because I always want to return the max, right? Okay. Yeah, here just shows an example code because I didn't want to go ahead and implement it in online GDB for sake of time. But simply, what I'm passing is, if I'm passing something like 1.2 and 4.56, what I will return is I will return just 4. Oh, that's black and black, but simply what you are returning is 4, not 4.56. Why? Because you lost track of the fraction once you translated or casted b from 4.56 into y, which is an int. So once this casting happens, y will be just 4 and x will be 1, right? From 1.2. Well, I'm just doing it in the wrong place. That's the function call. Good. Let me see questions and then I will move forward.
Professor, what's
Yep.
the logic in the int max function, like the x greater than y question mark? Like what's all that?
Sure. Let me say it for the third time. Okay. So,
Sorry.
and no worries. And again, we will revisit it. It seems a little bit complex because that's really Well, I would say I haven't seen this in any other language than C. C++ can inherit it as well, but Python, I don't know if Python has this expression. I didn't use it in Python
Yeah,
before, but at least in most like commercial Python-based programs, people really don't tend to use it. So it's just a very simple expression. And I guess Boran also, if yeah, he kind of formatted it a little bit in the chat to look better. So simply, you have a condition. This condition is followed by and sorry, it's followed by a question mark. And simply you are saying, is X larger than Y? That's the question. If so, you return the first type, like the first parameter in your choices, which is X. That's if it's yes. If it's no, you return Y. So if your condition is true, you return the first choice. If it's false, you return the second one, right? It's mostly commonly used really in low-level programming in embedded systems. I've seen it so much in firmware, for example. Some of you already said it's also common in React, JavaScript. Might be. I'm not very familiar with that, right? But the point is, you can really replace this expression with an if condition. If I want to rewrite it in F, it would be really as simple as saying if X larger than Y, then return X, else return Y, right? That's really what it means. Okay, good. Yeah, we also discussed this last time. If you have multiple source files, we said it's really highly recommended. I also uploaded a video on the playlist for this offering, going through some explanation of the different source files we have in the lab and why it's good to really have multiple header files and source files. By the way, something I forgot to mention is I see some of you already kind of coming and doing messaging on the channel on Teams to get the previous lectures, like the first one, so they are not in order anymore. And even the like Teams give them this serial naming that does not represent which lecture it is, right? So something I will try to do if I got the time is I will just like name them again, like create a playlist similar to what I have done in previous years, and then call it like lecture 1, lecture 2, and then also the title of what we are discussing there, right? Hopefully this also might be a little bit of good indexing or organization for you to go back to, instead of, well, today I wanted to go back to this lecture to see where did we stop, and then I found myself opening lecture 1 and lecture 2 because someone just posted them on the chat. So I don't know if you also kind of find this a little bit confusing, but I will try to do this if it's useful. Okay, good. So this is we kind of went through very quickly. Again, we said it's a good practice to have your source code. When we say source code, like for example, function implementation or prototype in your .c, and then your definitions in your .h files, similar to what we have done in the previous example, right? Good. C and Java are almost visually appealing in my opinion. Okay, so you guys are kind of discussing the C versus Python and those kind of never-ending arguments. Those are header files. Then we said you need to include your header file that has all the definitions, prototypes, compiled source files together. This means, if you remember from last time, we said, how does the compiler know when it does the linking stage that for this header file I included in my main? For example, last lecture we had my mean square.h included in the main, but then once you compile and run, the compiler is able to grab to obtain the source code implementation. The reason was that we said it's by default assumes all the source files are in the same directory or path as the header file, right? So simply combine source files together in one stage. This is called the linking stage, if you remember from last time. Not last time, in the lecture that we had the compiler flow through. Also, we went quickly through it last time. Good. Okay, so here, well, it just goes through the example, but we have already done this also last lecture, is that if I just add a header file, and you guys by after lab 0 should be also very familiar with this, is that I added all my definitions in a header file that maybe I can just call my math.h, and then I added the implementation of those functions in my math.c, and then inside my main I just include my math.h. By doing so, I'm able to use my sub function and also my add function if I would like, right? I guess this should be clear by now unless you have questions. Good. I'm going quickly through this because we have done already last time. So it should be just a quick revision. But if there are questions, please feel free to ask. Good. So one thing we mentioned, and we also started our lectures with, is we said, well, we are using printf and scanf. Those are functions, function calls to be very specific, but we never implemented them. And we were able to use them because we included studio.h, right? And we said, well, the C toolchain, the C standard library already has the implementation of these functions handy for us to use, right? So some of the common functions in the C standard library as well. It's a printf and scanf is one thing, or usually dealing with input output, but also math functions, right? So if you include math.h, which is, by the way, I believe, well, let me not, you will see in lab 1, like basically I will leave it for you to decide, but simply in math.h there are math functions that you can just simply use, right, without implementing them. This includes, if you like power function, for example, square root, sine, cosine, this kind of related math stuff. Also in C, and we have 2-3 lectures specifically for strings in C, because C, similar to Boolean, if you remember, we said C doesn't have any Boolean inherent type, right? It uses int for that. Also, it doesn't have, one of the big limitations in C, it doesn't have an inherent type called string, right? It deals with strings as a kind of an array of characters. And this really puts many rules for us to follow in when we deal with strings in C. And that's, from my experience, that's one of the most common interview related questions when you are asking about C in industry for internships or co-ops or even positions. The reason is this would require you to really understand arrays, sometimes pointers, and how to handle strings. So it combines multiple pieces of knowledge together. And for this reason, we really kind of dedicate 2-3 lectures for this. But here, what we need to know for now is to be able to handle strings in C, you should really make use of the string.h functions. Later on, I'll give you a few examples of these functions that are already implemented in string.h, right? And by the way, all the function prototypes and these header files, well, once you installed your C toolchain as part of your lab 0, if you are using Windows, like for example, MinGW, GCC, or if you had Mac, it's Xcode. The path you added for your system variables, where you put the path for MinGW, like toolchain. In fact, this path includes also all these header files and their implementations, right? So there is a way, if you search in your machine, you can really open the math.h file and look into all the functions there, right? A much easier way is just Google like math.h. All the actual documentation of C is publicly available, and you have access to all the prototypes inside math.h. If you ever wondered what other than square root and power and sine and cosine, there are so many other math functions that you can really have access to, right? The same thing for string and studio.h. Good. And there is another one called standard library.h or std lib.h, and well, this has more kind of a little bit advanced functions. For example, if you want to use dynamic memory allocation, as we will do by the end of the C part of this course, I guess sometime in late October, if we use malloc for memory allocation, we need the standard library.h. If you want some kind of pre-implemented algorithms for sorting or searching, also these are already existing in standard library.h. If you want a rand function to generate some sort of a random number, this is also included there. Good. Okay, if you want something to manipulate time, so there are so many header files in the C standard library. We will not go through all of them, but some examples from the math library. We mentioned square root, we mentioned exponential. There is the log 10, absolute value and power and sine, cosine, and tan, like the ceiling and floor. Some of you already asked before about ceiling and floor. All of these are already included in the math.h header file. Good. Any question? What is the use of h file? Doesn't this file do the exact same thing? No, right? We said the header file only includes the signature of the function, right? Not its implementation. The point is that to be able to access the implementation of a function, we said you need, well, the function journey has three things, right? The call, which happens within another function, its implementation and its signature, like its definition, right? Similar to variables, you cannot use a variable without declaring it. Functions is the same thing. You cannot use a function without really having its signature or its definition. This is the purpose of the header file. If you go back to lab 0, look into your test cases.c. I wanted to give a call to add function, right? And to be able to do this, I needed to include questions.h in the test cases.c, right? So you include the header file to have access to functions. Good. And last time we kind of went through some of why it's handy to really kind of also have header files. For example, if I want to give my implementation to someone, and I don't want him to go or her to go directly into the implementation, go through the maybe 1,000 lines of code of my function and then try to understand it. I just want him or her to be able to use it. What should I do? I just give him the header file, right? The signature. And by doing so, he or she should be able to use the header file, right? A very simple example for this is what we have done ourselves. We included studio.h, which has the definition of printf and scanf. We never went through how printf and scanf are implemented, but we were able to use them correctly, right? Right, and we never included the source file. It's only the header file that is needed there. Okay? Is the difference between apps and if apps? I used apps for one of the questions at work anyway. There might be some differences. I don't recall in C exactly, but maybe if apps also works for fractions, apps might be ends only. I'm not very sure, to be honest. This is something I have to relook in C. Okay. Yeah, I guess also Jack already kind of added a note there. Okay, thanks, Jack. Okay, so if you are fine with the header file, C file discussion and how to use functions, by the way, that's something that is very important, right? Because C doesn't have classes. It has structs later on, which is our last lecture. But other than functions, you cannot do much modularization in the C programming language, right? Later on, we'll see in C++, we will define classes, interface classes, and inheritance, all these kind of detailed things about encapsulation or OOP concepts in programming. But C somehow is a poor language in that sense, right? So most people, if you write a C code, your best way to organize your code is functions and header files and source files. So you need to make sure you really get this correctly, right? And again, labs should be able to help you in understanding this kind of structure, right? Okay, so now we will move to quickly to another topic in the remaining 10 minutes, which is local variables versus global variables. And it's good to discuss it here because we quickly touched on it when we discussed variables defined inside the function itself. If you remember my main square, we said once you exit this function, all the variables x and y and z get destroyed, and then you go back to the main, right? And we differentiated between a and b in the main versus x and y in your my main square, right? So let's see exactly what we mean by local variables versus global variables. Assume I am in main, I defined a variable up there, which is outside of any function, including the main, while I defined another variable inside the main, right? I call m a local variable because it's only local for the main. If you try to access it from another function, it's not recognized. But by is called the global variable because it's defined outside any function implementation, which means it's accessible by all the functions, right? Take it as a general rule. Any variable Its scope, when I say scope, basically when it's being recognizable, right? Like you can access it. Its scope is the block that you define this variable in. So if you defined it inside your main, then it's accessible by all other variables and expressions in the main, but not outside. If you defined it inside a for loop, you might be surprised that this variable will not be recognized outside the for. This is really a reason for one of the most common problems I see when I debug with students. It's like you define a variable inside your for loop, you try to access it from otherwise, like from outside the for, and it gives you an error, right? So the general rule is whatever block you define your variable in, this is the scope of your variable. You cannot access it from outside. Okay. Good. All of this is just what I'm saying right now. Let's see quick examples. So here I define, well, first of all, that's a function signature. I call it square. It takes no input parameter, so I can write void or nothing. And then inside the main, I'm calling square. And simply the implementation of square here is alpha multiplied by alpha, right? How do I know alpha if I didn't take any input parameters? I define alpha as a global variable here. Because it's global variable, any function can access it, right? So if we go to the, hopefully there is no visualization. I remember I had a visualization here. Okay, so let me just draw it myself. So simply going back to this memory image, right? If this is your big memory, this is your main memory scope. This is your square scope. And this is inside a stack, right? Another memory space, which is also related. Well, I will just extend my memory here. This is called the global scope, which is accessible by every function. If I look into the variables, let's look to all the variables that are defined inside this program. I will start with A. A is defined inside main, correct? That means it's a local variable for the main. So where should I put it? Should put it in the main scope, correct? If I try to access A from square, you will get an error, right? And then what other variables? I have alpha here. Alpha is outside the main and it's outside square. So it's really in the global scope. So I have it here. Because it's in the global scope, both square and main have access to it, right? So main and square use it to really pass values to each other. For example, here, if I just call square with no input parameters at all, what square does, it takes this global variable alpha, right, as 1.5, multiply by 1.5, and then return it. So A at the end will really take the value of 1.5 square, right? So in fact, you know what, maybe I just should go quickly and play around with online GDB with that. I hope you are fine if we stay the extra minutes afterwards. See, I will stop sharing and then share this one. I guess you are able to see online GDB, correct? So what I will do quickly is I will just write square here. Square return is double. Then call it square. And then it takes no input parameters at all. I will just put the full implementation here for sake of time. Then return alpha multiplied by alpha. And then I will define alpha in the global scope. So I would say double alpha, and then this would be equal 1.5 or anything, right? Then in the main, I will just define a variable, call it like double A, and then I will call the square function. And then I will just do printf, and this is a double. Then I'm returning A. Good. And then maybe just for sake of readability, I would say alpha equals, I print alpha as well, and A equals. And then here I'd say alpha and A. Okay, good. So that's the straightforward thing. So simply here I'm able to access alpha from the main, right? And from the square as well, right? So both functions have access to alpha because it's in the global scope. Good. While A is only accessible in the main. So let's run it and then we will do a few bad things to see how it works. So alpha is still 1.5 and A simply gets 1.5 square, right? If I change this program to say, you know what, I just want to return, let me define a third variable I call Z. And then in this case, I would say Z equal A plus alpha multiplied by alpha. So it's an expression that has a combination of A and alpha, right? And then I'm just returning Z. Good. Here I'm doing something wrong, right? Why that's the case? Let's see. If I just run, well, it should give me an error, but not kind of funny indefinitely. So it says, well, error A is undeclared here. But why that's the case? I already declared it here. Because you declare it in the main memory scope, not, sorry, in the main, yeah, in the main memory scope or in the main function scope, but not in the square one, right? Just for sake of visibility, I hope also you see the difference. That's this square function. This is the global variable, and that's it. So here A is not defined, right? Even if it's defined in the main, but it didn't give me the same error for alpha. So if I just remove A from here, well, it worked fine. Why? Because alpha is a global variable, while A was a local variable to the main. Is that clear? Good. So as you can see, like global variables can be used to pass values between functions without really passing them as an input parameter, right? If you think the logical way of doing this is, well, alpha shouldn't have been a global variable. It should have been just like a local variable to the main. And then I pass it as an input here, right? And then in this case, I just say I'm expecting a double to be passed, right? Oh. Correct? That's really the logical way. Like you pass an input parameter, you square it, and then you turn it square, similar to my main square that we have done before. In that case, alpha is no longer a global variable, but I really passed it as an input parameter. By the way, this can be any other name. I can call it theta if I would like, because, and this is theta. Because here I'm passing alpha to theta by copying, by value, right? So they shouldn't have the same name, or they might not have the same name, similar to the A and B and X and Y in our main square example, right? So theta input parameters to a function are really local variables to this function. So if I try access theta from here, I will get an error as well, right? But let's first of all run this. So what I have done is I don't have any global variables now. I just defined a very normal function, takes a single input parameter, square it, and then return it, right? Everything should be fine. Then if I run, I just get like alpha is equal 1.5 and A is equal 2.25, right? Good. This makes sense. Good. So if I try to access theta here, well, I really have a problem because theta is not defined. If I try to write alpha here, I would still get really undefined error, right? Because within this scope, there is no variable called alpha, right? So if you run, well, alpha is undefined because inside here, you only know theta and Z, right? Alpha is defined here. You're only able to access alpha if it remains to be a global variable, right? Which is the original case, right? Good. Does this make sense? Okay, so what else do we have? In fact, the discussion about global versus local variables, we will end by this. Don't worry, I'll just take a couple of minutes and then we should be ending. So the discussion about local and global variables might be confusing a little bit in when you really implement it yourself, but hopefully this kind of example makes it a little bit clear. So we said, well, global variables are defined everywhere. Block scope, any variable that is defined inside a block, it's only visible within this block. Already mentioned this. And function scope, if you define a variable inside a function but outside of any block, then this variable is accessible throughout the function itself. Good. Related to the global versus local discussion, also variables get stored in the memory for the period of their corresponding block. Remember when we said my main square, x and y and z are defined in this function. Once I return it from this function, the false space was destroyed. So I no longer has a variable called x and y and z, or x or y or z, right? So the storage duration is only within the block of the definition itself. A function local variable have automatic storage duration by default, which is it gets created when the function is called and it gets destroyed when we return from the function, right? Again, go back to the visualization of x and y and then my main square. It explains this a little bit. For this static thing, I wouldn't go through it because it's really something that would require more time to explain. So I will stop here and we will continue on Wednesday. Okay. So thanks everyone, and talk to you on Wednesday then. I will just quickly scan the questions. Yeah, thanks everyone. Have a great day, and then I will quickly go through the questions, and then I will talk to you later on Wednesday. So questions from beginning. What is the last one I answered? So it's the prototype function that makes the final decision for the type of the variable inside the function itself, right? Not outside it. So that's correct. What's the use of the h file? I guess I already answered this. The apps, I already went through it. Can we define a global variable with a value that is dependent on a function? I'm not sure exactly what you mean by this, Mayar, because in the global scope, you cannot really execute code, right? And that's another problem, right? So if you want to be dependent on a function, you need to do a call for this function, but you cannot call a function from the global scope. You have to call it within a function, right? What you can do instead is you can just give it any initial value, but then later on you update its value based on other functions, similar to what we have done for the alpha thing. I could have it change alpha. I don't know if I'm still sharing online GDB, but I could have just changed alpha here to another value, right? So I can just say alpha equal 2, right? And in this case, alpha will get updated. So a global variable can really get updated from anywhere. Yes, how does the code know how to connect alpha to theta? By the function call. This is what we explained in the my main square. Rayat is like when you do a function call, A and B get passed to X and Y in their order of call, right? So if you said my main square A and B, A goes to the first input parameter and B goes to the second one. So the order is as defined in the prototype. Liam, should each function have its own source and header files? This depends on the use case or the implementation, Liam. For example, if you define a group of functions do a similar job, something like the math, for example, math functions, well, it makes more sense to have them in one header file. Because if you write a very big program that has hundreds of functions, it makes no sense to really have hundreds of files, right? That's not very handy, I would say, right? So it's really dependent on the use case. The general advice is combine functions that achieve a certain goal or functionality in the same header file. Do not say question lab. For question 2 in the lab, can we the 5 digit be like 00 or something like 00345? I guess the lab document Abdul Nasser kind of explains this. Yes, this can be an input, and you have to handle these cases as well in your. If you are asking whether this can be really an input use case, yes, it can be a corner case input, and you have to be able to handle it, right? Okay, so thanks everyone, and I will talk to you on Wednesday then. Thank you. Bye bye.